This video was originally made for Japanese people, but I tried to add an automatic English voice to it. Please understand that there may be some parts that are difficult to understand. Last time I explained that the F-2 was based on the F-16 and modified to the point where it could be considered another type of aircraft. This time I'll try to explain in more detail the development process of the F-2, its design details, the differences between it and the F-16, and the modifications made. Development history of the F-2. The F-1 was operated as Japan's support fighter, i.e., the attack aircraft in other countries, but it was assumed that it would begin to be retired in the 1990s, and a replacement fighter was needed. It was initially called the FSX, short for Fighter Support or X. From now on, I'll basically call it the F-2. The F-2 was given the role of intercepting enemy aircraft and ships that were invading Japan, as well as countering the fighters that accompanied them. Unlike the F-1, which was also mostly an attack aircraft, the F-2 was the first domestically produced aircraft to be required to be able to engage in air superiority combat. With an eye on the future, the Japanese were developing the necessary elemental technologies. For example, integrally molded main wings made of CFRP, carbon fiber reinforced plastic, to increase strength while reducing weight, and CCV technology to increase the stability and mobility of the airplane at the same time. The world's first fire control system using ESA radar for a mass-produced aircraft, onboard computers for fighters, integrated electronic warfare system for aircraft, inertial navigation system, and research on stealth, etc. They succeeded in developing a variety of elemental technologies. In 1985, an inquiry was made as to whether it would be possible to develop a fighter aircraft in Japan that would meet the following requirements. 1. A combat operating radius of 450 nautical miles, 833 kilometers, with 4 anti-ship missiles. 2. The ability to be equipped with 2 to 4 short and medium-range air-to-air missiles. 3. The ability to operate in all weather conditions. And 4. Advanced electronic warfare capabilities. In September of the same year, the answer was given that everything except the engine is possible. At that time, engines for training planes were almost complete, but engines for high-thrust fighter had not yet been developed and were expected to be imported from the United States. The US and Japan had trade problems, and the deficit with Japan was very high, so we couldn't just say, we'll just buy the engines. Looking at the examples of other countries, the Israeli Lavi had Pratt & Whitney PW1120s, and it would have been nice if they could have done the same. However, it seems that the US couldn't give up this market, because the US support for the development of the Lavi was lost and it was forced to be cancelled due to lobbying activities, because the US market was threatened. It's also a military issue. So, the US insisted on importing American-made products to Japan. However, the Japanese side was finally able to develop an air superiority fighter, and since they had to maintain their military industry and pass on their technology, they resisted the importation, and this time the US offered joint development. Japan also opposed the joint development, but the possibility of further sanctions on the issue of Toshiba Machine's violation of COCOM, selling machine tools to the Soviet Union, and the issue of semiconductor sanctions, which would impose a 100% tariff on Japanese products, was presented. However, it is no longer just a matter of F-2 development, and Japan has been forced to make concessions. For joint development, modifications based on the F-15, F-18, and F-16 were considered. The cost of the F-15 was relatively high, the F-18 was expensive to develop and mass-produce. And since it was originally a carrier-based aircraft, it required various design modifications. The F-16 was thought to have lower development and mass production costs. Although the final reason for the adoption of the F-2 was not made clear, it was decided in October 1987 that the F-16 would be used as a modified mothership, and joint development of the F-2 between Japan and the US was agreed upon, and an MO was signed in November of the following year. Just when Japanese developers thought they could finally relax, a new problem arose. Organizations other than the DoD and the Congress came out with strong opposition to the joint development, and the American press made a big deal out of it. As a result, the licensed production of engines was somehow approved, but the provision of the source code for the flight control computer was banned, and it was decided that the US would basically have free access to the technology owned by Japan, and the technology would be transferred. It's been a pretty tough deal, but we've managed to develop a fighter with a high-powered engine. The development of the F-2 became quite a political issue and was very difficult. Just remember that the disclosure and transfer of technology was a problem for both Japan and the US. This is something that will linger in the design stage. I will now explain the development of the F-2. focusing on the opinions of the designers. Design of the F-2. As I mentioned earlier, the F-2 was to be modified from the F-16, and the blueprints and design documents for the F-16 Block 40 were provided by the U.S. From the consideration stage of the base aircraft for the conversion, GD had proposed the idea of the SX-3, an F-16 conversion. The SX-3 was a concept that increased the wing area of the F-16 by 25%, increased the aspect ratio of the main wings, and used more carbon fiber composite material in the wings and fuselage, 42% by weight. The basic design is almost the same as the one proposed for the U.S. Air Force as the Agile Falcon. Japan initially considered modifying the F-2 based on this design. However, when the performance of the SX-3 was calculated based on blueprints and other data, it was confirmed that there were areas of insufficient performance, such as a flutter of the main wings. In addition, it was decided that the modifications would be based on the F-16 Block 40, not the SX-3, due to the lack of necessary drawings, evidence materials, and flight records to use as a base for the modifications. The engineers on the American side did not leave any data on the calculation process related to the design, and the know-how was held by each engineer. For this reason, it was difficult to make the modifications without knowing the basis for the calculations from the design drawings and calculation results alone. After informing the U.S. side of this, they were able to check the aircraft and receive technical training by experts at the factory in Texas, which was very useful training. The transfer of the F-16 technical data was carried out after the Japanese side compiled a list of necessary data and coordinated with the American side. It took some time to select the materials that could be provided by the U.S. and to correct the parts that they did not want to be disclosed before the transfer. The Japanese side wanted the information as soon as possible, because if they could not disclose it, they would conduct the necessary tests themselves. On March 30, 1990, the design team FSET was established. At that time, the team consisted of 104 people, 72 from Mitsubishi Heavy Industries, 11 from Kawasaki Heavy Industries, 11 from Fuji Heavy Industries, and 10 from GD, reaching 330 at its highest. Mr. Kondo Kuniichi was the team leader, with 4 representatives from each company as sub-leaders, and 6 offices under him. Based on a MO between Japan and the U.S., the development work was managed by a technical management committee between the governments of the two countries, and communication between the U.S. and Japan was carried out. The main contractor is Mitsubishi Heavy Industries, which oversees the Japanese and U.S. partner companies, Kawasaki, Fuji, GD. The defense agency supplied the electronics and engines, and Mitsubishi was responsible for the design and prototyping up to the internal flight tests. Mitsubishi Electric Corporation was in charge of the fire control radar and integrated electronic warfare system. The engine was developed by General Electric, and EHE produced it under license. The flow of development work is as shown in the figure. It is mainly divided into basic design, detailed design, prototyping, internal test, and practical technical test after delivery to the defense agency. The basic design will be done in cooperation with the FSET design team. The team will prepare specifications to be complied with for the new technology, perform design and calculations to realize the development specifications presented by the defense agency, and create a blueprint. FSET will create the mock-up and the simulation part of the flight control. After that, each company prepares manufacturing drawings based on the blueprints and manufactures the product. Prototype production and internal test will be carried out by AMHI, and thereafter, the defense agency will conduct technical practical tests. The figure shows the areas of detailed design that each company will be responsible for. Mitsubishi was responsible for the upper front fuselage and part of the main wings, Fuji for the underside of forward fuselage, part of the main wings, and the tail, Kawasaki for the intermediate fuselage, and GD for part of the left wing, leading edge flaps and aft fuselage. Major modification from the F-16. What was required in the development of the F-2 was to add anti-shipping capability and apply new technology without compromising the good points of the F-16. The design team believed that there were 3 fuselage shapes that could produce the superior performance of the F-16. 1. The blended wing body, which has a smooth flowing shape that extends from the upper fuselage sides to the upper surface of the main wings. 2. The engine air intakes are located under the fuselage. 3. The strakes are connected to the fuselage by a smooth bend in a line extending forward from the leading edge of the main wing joint. This shape was retained to try to ensure excellent flight performance. The main changes from the F-16 Block 40 are as follows. 1. Increased main wing area to improve turning performance. 2. Use of advanced materials and technologies such as CFRP composite materials to reduce weight. 3. Adoption of the world's first ESA radar for a mass-produced fighter aircraft to improve fire control capability. It is also equipped with advanced electronic equipment such as an integrated electronic warfare system. 4. To improve takeoff and landing performance, it has adopted an engine with improved thrust. 5. Radar-absorbent material is applied to improve stealth. I'll explain each of them in detail. The F-2 was designed to carry a large number of anti-ship missiles to intercept the enemy. The wingspan had to be increased to accommodate the external fuel tanks that would sometimes be suspended at the same time. In addition, the wing area was increased by 25% compared to that of the F-16 in order to increase the cruising range in that condition. This value is the same as that of the SX-3, which was a modification of the F-16. But it was just the result of a calculation based on the thrust-to-weight ratio and wing loading that resulted in the same value. Therefore, the shape and structure of the wings are completely different. In order to make the enlarged wing as light as possible, composite materials such as carbon fiber reinforced plastic, CFRP, were applied to about 18% of the structural weight of the main wing, tail wing, and outer fuselage panels, and titanium alloy was applied to about 8%. As a new structural technology, they succeeded in molding the main wing girders and lower outer panels in one piece without using fasteners, which were conventionally joined with fasteners. The holes for fasteners were eliminated, leading to weight reduction and strength enhancement, as well as reduction in the number of parts and man-hours. This composite material technology was developed by Toray and other companies around 1960 to improve the application technology, and later developed into a unique technology for integrated molding of aircraft wings under the leadership of the Technology Research Division. Actually, the US had the technology to make composite materials, but GD lacked the technology and wanted it. Japan was forced to make a concession and provide the technology. I've heard some negative comments about this, but I'd like to put a positive spin on it. This is because when the wings of the Boeing 787 were later made, it was suggested by Mitsubishi that they be made of composite materials, and this technology became widely used. Even today, Japanese manufacturers still have a large share of the carbon fiber market, so I think they contributed to the expansion of their customer base. Along with aerodynamic performance, the radar is important for fighters to detect their opponents quickly. Previously, the radar was operated mechanically by moving an antenna to receive and transmit radio waves. The F-2 is equipped with an active phased array pulse Doppler radar that can receive and transmit radio waves from individual semiconductor modules without mechanically moving the antenna. It was the world's first mass-produced aircraft to use this technology. This JAPG-1 fire control radar has a number of modes, including air-to-air, dogfight, missile overload, air-to-ground, and air-to-ship. Although its performance has not been disclosed, it is estimated that it can simultaneously process more than 10 targets, and that its maximum detection range is 185 km for large targets such as ships, and around 65 km for fighters at lower altitudes than itself. In addition, it is said that more effort is being put into improving the target decomposition and look-down capabilities than the maximum detection range. Oh, by the way, there was a time in 1975 when they couldn't find a Soviet fighter plane. They lacked the look-down capability at that time. As for the four most important and complex avionics in a fighter, in addition to the aforementioned, 1. Fire control radar, 2. Inertial reference system, 3. Mission computer, and 4. Electronic warfare system, they are being developed independently in Japan as originally planned. In addition, color LCD instrument panels and head-up displays were also developed. It's not that they tried to use domestically developed products at all costs. First, there are some things that are not provided by the US. For example, electronic warfare systems were not provided for the F-15s either, so they had to develop their own system from that time. Also, the source code for the flight control of the aircraft was initially expected to be provided, but was not due to opposition from the US Congress and others. Fortunately, Japan has developed the T-2 CCV for research on CCV technology, and they were able to prepare it themselves. And, they were not going to use the F-16 as a modified mother plane at first, but were going to develop the fighter only domestically except for the engine, and the Defense Agency's Technical Research Headquarters had already developed the necessary elemental technologies for the fighter domestically. Composite materials, future fighter shapes, CCV experimental aircraft, future fire control devices, onboard computer for fighters, integrated electronic warfare systems, inertial navigation systems, stealth, Other systems, such as those related to descent and landing, propulsion, fuel, air conditioning, communication and identification, and operation and display, basically followed those of the F-16 Block 40, but were modified or changed for functions that did not meet the performance requirements of the F-2. For other subsystems and equipments, they asked for 50% licensed production, but were turned down by the US government. As a result, only the 10% that was truly necessary was produced under license, and the rest was either developed domestically or imported as finished products. This, in turn, promoted Japan's own development. Another change from the F-16 Block 40, although not a Japanese development, was the replacement of the engine with one with increased thrust. This is important because the increased thrust will make a big difference in the shape of the aircraft and the amount of missiles it can carry. The F-16 was compatible with two types of engines, but the Japanese would only use one type, so they could choose a more optimized airframe shape. Radar-absorbent materials were installed on the leading edges of the wings and inside the air intakes to reduce the RCS compared to the F-16. However, hanging a large missile would make it more visible to radar, so it was a little stealthy. I've explained the major changes so far. Other than that, there are many other changes such as stronger windshield, larger nose, longer fuselage, new shape of the horizontal tail, and changes to the APU, but it's too long to go into here. The performance of the F-16 has been continuously improved through upgrades, but at the time, most of the technical data provided by the US was early, about 20 years old. If the results of tests conducted during that period were also provided, it could be said that the data was mature, but this was not the case. In the development of the F-2, Japan did not buy the technology from the US, nor did it receive it from the US, but rather acquired the development technology on its own. By adding new proprietary technology developed through repeated testing to the F-16, Japan was able to create the advanced fighter aircraft of its time. Improvements after mass production. The F-2 first flew in 1995, and mass production of the aircraft began in 2000, with 94 aircraft mass-produced. As with other fighter planes, some problems were found in the early stages of operation, but countermeasures were taken and the aircraft is now in operation without any problems. With the exception of the engine, many parts of the aircraft were developed domestically, and subsequent updates have improved its performance. The following is an explanation of the improvements made after mass production. Based on the lessons learned from the 1991 Gulf War, the development of the JAQ-2 external forward-looking infrared was started in fiscal year 1996 to perform missions at night, in bad weather, and in an electronic warfare environment. Infrared images are displayed on the display, and the system is capable of searching and tracking ground targets and ranging. However, it does not have the function of a targeting pod. Deployment began in fiscal year 2007. The ANEA Q-33 Sniper was selected as the targeting pod to operate the laser JDAM, and from fiscal year 2014 to 2018, it was retrofitted to the aircraft and practicality evaluation tests were conducted. Currently, it is deployed on only a small number of aircraft. Starting with the aircraft contracted in 2004, the JDAM operational capability, which enables precision guidance of conventional bombs using GPS, has been granted. Earlier aircraft have also been upgraded and are now operational. Since fiscal year 2010, in order to improve air-to-air capabilities, the fire control radar has been upgraded to JAPG-2 and modified to enable the launch of AIM-44B domestically produced air-to-air missiles with fire-and-forget capability. Some believe that the JAPG-2 radar is more powerful than the ANAPG-79, but details are unclear. Since fiscal year 2011, the F-2 has been retrofitted with equipment for the JSDF digital communication system, a data link with fighter aircraft and air defense command centers. It is said that this equipment was installed because the space and budget of the aircraft made it difficult to install Link 16 equipment. The upgrade is being carried out from fiscal year 2020 under the name of F-2 Capability Improvement Upgrade. In addition to the installation of the Link 16, the F-2 will be given the ability to operate the ASM-3, a missile capable of Mach 3 or higher, and the mission computer will be replaced. How did you like this video? I wanted to reiterate that the F-2 is a completely different aircraft, with 95% of the blueprints changed from the F-16. The development of the F-2 was the first joint development of a fighter aircraft between Japan and the US, so there were a lot of adjustments to make. But I would like to think that it strengthened the alliance between Japan and the US and the defense industry. Since there are military powers such as Russia and China in the vicinity of Japan, I would like to place particular importance on the Japan-US relationship. Japan will take the lead in the development of the F-3 fighter, the successor to the F-2, in cooperation with foreign companies. To be honest, I don't know what kind of fighter planes will be needed in the 2030s and 2040s, or what kind of battles they will be expected to fight, but I hope that they will be able to cooperate with other countries to promote regional stability. Thank you for watching to the end. Feel free to write comments. If you like it, please like and subscribe to my channel.